Here we see the initial stage where workers are cutting rusty steel rebar into smaller pieces. A powerful hydraulic shear slices through the thick iron bars with ease. This heavy-duty cutting machine generates a lot of debris as it processes the steel. We can see a glimpse of the industrial yard where this manufacturing takes place. Two workers manage the large flywheel mechanism that powers the machinery here. One worker walks towards the next workstation inside the workshop. Look at this massive pile of cut rebar waiting to be processed further. The sheer volume of raw material stacked up here is quite impressive. A worker manually selects lengths of rebar from the heap for cutting. He carries the heavy steel rods over his shoulder to the cutter. Back at the hydraulic press, another worker positions a fresh bar. The operator uses foot pedals or levers to activate the cutting action. With each press, a precise segment of the rebar is sheared off. The camera zooms in to show the pressure applied to the steel. The blade pushes down, snapping the thick rusted rod cleanly in two. This repetitive process is crucial for preparing uniform raw materials. The freshly cut pieces are tossed onto a growing pile on the floor. These cut sections will eventually become the cores of our bearings. The texture of the rebar helps grip the concrete later when used structurally. Now a different worker picks up longer bars for a different type of cut. He feeds a straight piece of metal into a guillotine-style shear. This machine operates with a quick downward strike motion. It is efficient and requires minimal effort from the operator. Close-up shots reveal the clean edges left behind after the cut. Small metal fragments fly off as the shear engages the rod. A basket begins to fill up with the standardized chunks of steel. Each chunk has a consistent size which is vital for mass production. Another worker starts collecting these chunks from the cutting area. He gathers them by hand and places them into a wide metal basin. Preparation for the heating phase is underway in the workshop. He carries the full basin over to the furnace set up nearby. Inside the barrel-shaped furnace, a fire is burning intensely. He carefully tosses the cold steel chunks into the hot coals. The goal is to raise the metal temperature until it is malleable. You can see the flames licking around the pieces inside the barrel. More chunks are added rapidly to ensure efficiency in the process. He layers them carefully to allow heat to penetrate every piece. The side view shows the intense orange glow from within the oven. A blower attached to the pipe helps stoke the fire even hotter. A worker checks the temperature using a metal rod. Once hot enough, he pulls out a glowing orange piece of metal. This hot billet is immediately moved to the power hammer station. The operator positions the red-hot metal precisely on the die. The hydraulic press slams down with immense force on the soft metal. Smoke rises as the high temperature meets the cooler metal mold. The hammer strikes multiple times to compress the shape instantly. Steam shoots out as the metal is flattened into a rough disc shape. After forging, the pieces are dropped into a container to cool down. This bucket is filling up with these newly formed semi-finished domes. Some parts are still bright red, indicating they just came off the press. Workers begin sorting through the cooled, blackened metal pieces. They pick out the good ones and discard any deformed scraps. Sorting ensures only the best quality parts move to the next stage. The consistency in their rough shape is quite noticeable here. These forged blanks will soon undergo precision machining. A worker loads a fresh batch of these domes into a tray. He carries the tray deep inside the workshop where lathes are located. The interior of the shop is filled with various heavy machine tools. He approaches an older, well-used industrial lathe machine. He sets the tray down and prepares to mount a workpiece. Using a chuck key, he secures one of the forged domes tightly. The lathe spins up, rotating the metal part at high speed. A cutting tool moves in to shave off the excess scale and roughness. Metal shavings spiral away as the outer surface becomes smooth. The contrast between the rusty exterior and shiny steel is stark. This turning process gives the bearing its precise spherical form. The operator carefully adjusts the depth of the cut for accuracy. Finished, turned pieces are set aside on the floor. These now have a clean metallic ring around the equator of the dome. A large bowl collects a significant quantity of these processed items. Another worker takes over to continue the production line. He clamps another part into the lathe for the next operation. This time the tool focuses on drilling or boring the center hole. Metal swarf accumulates rapidly around the cutting point. The drill bit penetrates deep into the center of the forged dome. Constant rotation removes material to create a perfect central bore. This hole is essential for the component to function correctly later. The operator monitors the process closely to prevent breaking the bit. Once the hole is drilled, he unclamps the finished part quickly. He inspects it briefly before tossing it onto a pile. The ground is littered with hundreds of these identical metal rings. The repetition highlights the scale of this manual factory operation. Another worker sits on the floor, managing the inventory of parts. He sorts the pieces, separating those that need more work. Quality control happens right there on the workshop floor. He moves parts into buckets, preparing them for packaging or shipping. The piles grow larger as the day progresses. A worker walks through the shop, carrying a bowl of sorted units. He places them back near a lathe for a final finishing touch. The machine spins the part again for polishing or deburring. Fresh shavings fall away, leaving a polished silver surface. The inner bore is widened slightly for tolerance requirements. The operator uses his finger to clear away loose metal dust. Precision machining turns rough castings into usable engineering parts. The shiny finish reflects the light beautifully in the dark workshop. Finally, the finished product is removed from the chuck safely. A large collection of the completed bearing shells is shown. A worker gathers these up into a metal pan for transport. He scoops them up rapidly, stacking them efficiently. Carrying the load, he moves towards another section of the shop. The cycle continues as he brings them to the next station. He dumps the bowl contents onto the bed of the machine again. Ready to repeat the process for another batch of parts. Here we see a skilled worker operating a classic manual lathe in a rugged workshop setting. He secures a raw metal casting into the chuck and begins the turning process with precision. Watch as the cutting tool peels away layers of metal to shape the outer diameter smoothly. Coolant is not visible, but the shavings indicate dry cutting, which requires significant skill. Now he shifts gears to bore out the center, hollowing out the interior of the heavy part. Once the internal threading or diameter is perfect, he carefully unloads the finished unit. Look at this pile of identical cast components waiting for their turn on the lathe. They appear to be heavy-duty industrial parts, possibly valve housings or bearings. The repetitive nature of this work highlights the mass production capacity of this small workshop. Next station shows another craftsman working on a much larger, longer bar stock material. He is machining a complex profile, rounding off a section that will eventually become a sphere. A second person assists him by supporting the tailstock end to prevent vibration during cutting. Using a specialized form tool, he cuts deep grooves to define the curvature of the ball shape. Sparks fly as the tool bites deep into the steel, removing volume rapidly. You can see the distinct lines forming as the rough cylinder transforms into a smooth sphere. This level of manual shaping ensures every angle matches the required specifications perfectly. The operator adjusts his grip multiple times to ensure the surface finish is flawless. Finally, with a few light passes, he brings the surface to a mirror-like shine. He cuts off the connecting web, releasing the individual ball component from the main rod. Notice how cleanly he separates the part without damaging the delicate rounded surface. This process creates a high-precision ball bearing or ball joint used in heavy machinery. The sheer amount of metal waste shows how much material is removed to get the final shape. Each pass adds another layer of refinement to the geometry of the object. It is fascinating to see how simple tools can create such complex geometries manually. The finished balls are collected ready for the next stage of finishing. A bucket is filled with these shiny metallic shells, showcasing the results of the machining work. A worker inspects the surface quality, ensuring no defects remain on the exterior. These hollow metal domes look incredibly strong, yet lightweight, relative to their size. We move to a sorting area where workers are preparing the pieces for bulk processing. One worker sits on the ground, carefully organizing the loose metal parts into smaller piles. Another man threads these spheres onto long metal wires to group them together securely. This bundling technique allows them to handle many items at once during the heat treatment phase. The camera pans over dozens of these chains, lying on the dusty factory floor. It seems they are preparing for a galvanizing or plating process, given the wire arrangement. Back at the lathe, we see a different task involving polishing or deburring the open ends. The worker holds the spinning part against a handheld tool to smooth out any rough edges. This manual sanding step is crucial for removing sharp burrs left by the cutting tools. Close-up view reveals the texture of the metal changing as the abrasion takes place. After smoothing, the parts are dropped onto the floor in a heap near other tools. They gather these processed pieces to move them towards the thermal treatment area. The sheer volume of inventory here indicates a very active and busy production line. Every piece reflects the light differently, showing slight variations in the surface finish. The workers handle them casually, suggesting they are durable enough to withstand rough handling. Moving outside, we see bags stacked up, likely containing raw materials or waste. A worker empties a large sack, dumping hundreds of metal spheres onto the concrete floor. Another man quickly sorts through the pile, checking for any damaged units mixed in. He picks up handfuls of the small metal beads, inspecting the threading or inner holes. These small details matter for the mechanics mechanical function of the final assembly. He continues to organize them, grouping them into manageable batches for transport. This manual labor ensures that only quality products proceed to the coating station. He starts threading a new batch, working rhythmically to build up the chains again. The repetition shows the endurance required for this type of manufacturing work. With a full chain ready, he stands up to carry it toward the furnace area. Here stands a crude but functional furnace burning intensely to melt metal alloys. A worker lowers the chain of spheres into the glowing orange bath of molten material. This could be a zinc bath for galvanization to protect the steel from rust. He holds them steady beneath the surface to allow even coverage of the coating. The intense heat creates a steam fog as moisture evaporates instantly from the metal. He lifts the chain out, letting excess liquid drip back into the crucible pot. Immediately, he plunges the hot chain into a nearby water tank for rapid cooling. This quenching process hardens the metal and sets the protective layer on the surface. Steam rises vigorously as the thermal shock hits the cold water surrounding the parts. The contrast between the fire and the water highlights the extremes involved in this craft. He pulls the chain out of the water, shaking off droplets before placing it down. The parts now have a dark, matted finish, indicating successful chemical treatment. Before leaving, let us check the hardness of these treated components using a pressure tester. A worker places a single sample under the indenter of a Brinell hardness tester. He applies immense pressure to the surface to gauge its resistance to deformation. The dial gauge measures the penetration depth, verifying the structural integrity of the ball. The treated parts go through a cleaning phase to remove flux residues and dirt. Workers pour the spheres into a perforated metal basket designed for washing cycles. They submerge this basket into a large tub filled with chemicals or soapy water. Agitating the basket helps scrub away any remaining contaminants from the surface. Two men lift the heavy basket out, draining the dirty liquid back into the vat below. They repeat the process in a freshwater tank to rinse the components thoroughly. Clean water flows freely through the mesh, carrying away the sludge from the previous steps. This rinsing stage is essential to prevent corrosion and prepare for final polishing. They shake the basket violently to dislodge trapped water inside the hollow spheres. Water drains rapidly, leaving the metal damp but significantly cleaner than before. The clean wet spheres are transferred into a larger blue plastic container for transport. Workers add more fresh water from jugs to ensure every single sphere gets a good wash. They slosh the water around vigorously, using gravity to agitate the parts inside. The sound of metal clinking against metal confirms the thoroughness of the agitation. Next stop is the rotary tumbler, a large drum mounted on a motorized frame. Men carry the baskets over to deposit the cleaned parts into the rotating barrel. The barrel spins continuously to tumble the parts against each other or abrasive media. Inside, the friction polishes the surfaces and removes microscopic imperfections. You can hear the rumble of the machinery as it processes the load efficiently. A worker stops the machine to check the progress or add finishing compounds. The perforated sides allow liquids to drain while retaining the solid metal objects inside. As the drum rotates, it creates a constant rolling motion for uniform finish. This automated tumbling saves hours compared to manual buffing by hand. Another worker enters wearing protective gloves to handle the potentially hazardous contents. He reaches into the spinning drum to rearrange or extract specific samples. Safety precautions seem minimal here, emphasizing the rough nature of the environment. He wipes the lid or checks the mechanism to ensure everything runs smoothly. With the cycle complete, he unlatches the door to reveal the polished goods inside. Open the door and you see the collection of shiny silver balls gleaming in the light. A final inspection shows they are free from burrs and coated evenly. The worker scoops the finished parts out into a bucket for packaging. He grabs handfuls of the completed product, feeling satisfied with the result. The transformation from rough cast iron to shiny commodity is nearly complete. After watching this, the workers remove the freshly cleaned fabrication process. These semi-finished pieces are carefully emptied into a rinsing bath. Submerged in water, they undergo a thorough washing cycle. The basket is shaken vigorously to remove any residual sludge. Excess water drains away through the perforated holes. Now ready for the next stage, they move to the chemical station. Here, a special solution prepares the surface for coloring. Dipping them into the yellow liquid triggers a color change. Watch as the dull silver transforms into bright gold instantly. This chemical reaction gives the brass its characteristic shine. Each sphere needs to be fully coated for uniform appearance. The dipping process is repeated until all batches are treated. Once colored, the baskets are lifted out to drip dry. The workers inspect the golden hue before moving forward. Next, the wet components are poured into a drying machine. A high-speed centrifuge spins to force out remaining moisture. This step ensures no water spots mar the final finish. To accelerate drying, a worker switches on the heating element. The internal heating helps evaporate water trapped inside. The intense rotation keeps the parts moving constantly. Heat and motion work together to prepare the surface. Moving the flame ensures every sphere gets heated evenly. After heating, the machine is switched off to cool down. Workers wait briefly before opening the heavy cylinder. Safety is key when handling hot industrial equipment. 2 men lift the weighty container with care. They transport the dried batch to the packing area. The cylinder is tilted to release the finished goods. A cascade of golden brass balls rolls out onto the sacks. These hollow spheres will likely become decorative fixtures. Notice the smooth texture and reflective metallic surface. The manufacturing process guarantees consistent quality. These polished brass parts are now complete and ready.